In this video, we're going to talk about the intersection of a circle with a line. So first question, at how many points may a circle and a line intersect? Well, why don't we draw up the possibilities? So why don't we draw a circle here? And then let's draw a line. Maybe the line goes right through the circle, like this. And here we see that there are 2 points of intersection. Are there any other scenarios we can create? Why don't we try? So there's our circle, and what if we shift the line up or down? Will that change the number of points of intersection? Well, the number of points of intersection will remain 2 until we get to the very top or very bottom of the circle. Why don't we just draw on the very top? Once we have the line on the very top of the circle there, then there's really only a single point of intersection. In the case of this one point of intersection, we say that the line is tangent to the circle. Alright, so any other scenarios? Well, what if we keep on moving the line upwards? And then we get something like this. In this case, the line and the circle don't intersect at all. So we have 0 points of intersection. So there we have it. There are all the possibilities. 0, 1, or 2 points of intersection. Here's another problem. We want to find the points of intersection of the circle x squared plus y squared equals 2 with the line y equals 2 minus x. Now, really, this is just a system of equations. We've got 2 equations, each involving x and y. So what we can do to solve it is we can substitute one of the equations into the other. And we know that we can solve systems of equations by substitution. Here we've got an equation which is already solved for y. So we've got y in terms of x. So all we really need to do is take that y, take that expression for y, and plug it in for y here in this equation. So we'll do that here. We'll have x squared, then plus y squared, and y is just 2 minus x, according to our second equation. So x squared plus 2 minus x squared is equal to 2. Now we've got a single equation of x, and we can solve it. So we get x squared. We expand out this squared binomial to get plus 2 squared is 4, then minus 2 times x, so minus 4x, and then plus x squared. And that's equal to 2. Now let's go ahead and combine like terms. So we've got an x squared and x squared. Those combine to give us a 2x squared. Then we have our minus 4x and a plus 4, but we also have an equals 2 on the other side. So why don't we go ahead and subtract 2 from both sides of the equation to get the right-hand side to 0. Then we just have a plus 2, because 4 minus 2 is 2. So that's equal to 0. We see all the coefficients are even, so we can simplify this equation by dividing by 2. So we'll do that and get just x squared minus 2x plus 1 equals 0. And hey, that left-hand side is a perfect square. That's just x minus 1 squared. So x minus 1 squared equals 0. Take the square root of both sides to get x minus 1 is equal to 0. Square root of 0 is just 0. So x equals 1. So there's our x coordinate, and to find the y coordinate, we can just go ahead and substitute this value of x back into the equation for y. Y equals 2 minus x, so y equals 2 minus 1, which is also equal to 1. So putting this together, we have a single point of intersection. X is 1, y is 1. Here's another problem. Find the points of intersection of the circle x minus 1 squared plus y plus 2 squared equals 5 with the line y equals negative 2x. So again, our strategy is the same. We've got y equals negative 2x, so that's y in terms of x, and we can substitute that in for y in the circle equation. Doing that, we get x minus 1 squared plus y plus 2 squared. Y is negative 2x, and then we've got our plus 2, and that's all squared, and that's equal to 5. And now we have an equation with just x, so we can solve it. So let's do that. X minus 1 squared. That becomes x squared minus 2x plus 1. And then negative 2x plus 2 squared, that becomes, well, negative 2x, that quantity squared, is 4x squared. And then plus 2 times the first term times the second term, 2 times negative 2 times 2 is negative 8, and we've got an x in there. And then plus the last term squared, so plus 2 squared, which is 4. And that's all equal to 5. Okay, great, so we've expanded this out. Let's collect up like terms now. X squared plus 4x squared is 5x squared. And negative 2x minus 8x, that makes minus 10x. And then 1 plus 4 makes 5, and the right-hand side is still 5. Let's go ahead and subtract 5 to get that right-hand side equal to 0. So we just get 5x squared minus 10x is equal to 0, because the minus 5 cancels with that existing 5. We notice that these coefficients 5 and negative 10 are divisible by 5, so let's go ahead and divide by 5 to simplify our situation. We just get x squared minus 2x is equal to 0. And hey, that's factorable pretty easily. Both of these terms have a common factor of x, so factor out an x. So x times x makes x squared, then x times minus 2 makes minus 2x. And then we set the factors equal to 0. So one solution is just x equals 0, and the other solution is x minus 2 equals 0, in which case x is equal to 2. Now we go ahead and back substitute to solve for y. We back substitute into this line here, y equals negative 2x. If x is 0, then y equals negative 2 times 0, which is just 0. And if x is 2, then y equals negative 2 times 2, which is negative 4. So here we've got a solution: x is 0, y is 0, and the other solution is x is 2, y is negative 4. So there are points of intersection. We've got 2 points of intersection, 0, 0, and 2, negative 4. Here's another problem. Find the points of intersection of the circle x plus 5 squared plus y squared equals 1 with the line y equals x minus 5. Again, we have the same strategy as usual. Take that line, since it's already solved for y, and substitute that into the circle. Basically take the simpler equation and substitute into the more complicated equation. So x plus 5 squared, then plus y squared. Y is just x minus 5. That's squared, and that's equal to 1. So now we go ahead and expand out. X plus 5 squared becomes x squared plus 2 times x times 5, so plus 10x, then plus 5 squared, which is 25. And x minus 5 squared becomes x squared, then minus 2 times x times 5, so minus 10x, then plus our 5 squared, so plus 25, and that's equal to 1. Now let's go ahead and simplify. We've got an x squared here and an x squared there, so that's 2x squared. Then the 10x and the minus 10x, those can cancel. And then 25 plus 25 makes 50. So 2x squared plus 50 equals 1. All we have is an x squared in this equation, so why don't we get that alone on its own side? So we'll go ahead and subtract off this 50 from both sides to get 2x squared equals 1 minus 50, which is negative 49. And then divide by 2 to get x squared is equal to negative 49 over 2. Taking the square root, we would get x equals plus or minus square root of negative 49 over 2. But this is the square root of a negative number, and the result of that is not a real number. So we have no real solutions for x. And since any points of intersection would have to have real coordinates, we conclude that there are no points of intersection. So now we know how to calculate the intersection of a circle with a line. And in the future, we'll continue learning how to calculate the points of intersection between two curves.